Hello, and welcome to the recorded content for the Early Adopters track in the Water Loss TAP. This is Wave 1 workshop content, specifically with Segment 2. This is Will Jernigan presenting this segment, and if you are watching Segment 2, hopefully you've had a chance to review Segment 1 in the Early Adopters track, where Kate Gassner talked about a review of AWWA M36 Foundations, water auditing, water audit software, data validity, and some of those foundational concepts that, as a participant in the early adopter track, you should be familiar with already and have reviewed. What we're going to focus on for this particular segment is the Level 1 validation methodology and applying that to our water audit, and then getting ready for Wave 2. So let's go ahead and dive in. We'll get into what's referred to as a Level 1 validation methodology. We'll learn what that means, where it's coming from, and what is involved in the process. Starting at a high level, the Level 1 validation, you can consider it a top-down review of the information that's really behind those inputs in the audit and those grades that are in the audit, getting one layer deep to where those inputs were derived from and the basis for the grades selected in the audit. It really is applying a formal review process to that. And through this segment, we're going to learn what are the steps involved in that process. But to get us started in that discussion, we'll say that those are generally looking at the policies and practices behind the data grade selection and the derivation, as well as the documentation for the inputs that are going in. One of the key outcomes of the Level 1 validation is to identify if there are any indicators of underlying issues with data accuracy, or perhaps some embedded inaccuracies that aren't necessarily evident on the surface, but there may be some indication of them buried deeper. And so we'll affectionately refer to those as gremlins as we roll through and learn more about this process. The Level 1 validation methodology that we will be learning about in this program is being modeled after a research project that is currently underway. It's actually soon to be completed, being done through the Water Research Foundation, called Establishing Water Utility Guidance, a methodology for water audit validation. This is something that's important for the industry, and so the program in California is intended and purposely being modeled after the results that are forthcoming from that research project. One of the outcomes of that research project, and actually a couple of previous research projects that had alluded to the notion of validation within water audits, looking at water audits across the country, and some of these inherent challenges in the data from the data systems that we have in place, is recognition that validation occurs at different levels, and characterizing self-reported or audits as self-reported of those who have not been through a formal validation process. It doesn't mean that the audit itself is inaccurate. It just simply means that it's not been formally reviewed to determine the level of validity. Level 1 validation is generally, as we've said, considered sort of a top-down approach, and there are more advanced levels of validation, 2 and 3. The focus of this program, and specifically the mandate from Senate Bill 555 in the state of California, is dialed in on Level 1 validation. So the purpose in articulating this is to make sure that the participants are aware that there are advanced levels of validation, and in some cases, some of the utilities may actually already be engaged in these. Level 2 are generally, validation activities are generally characterized by data mining, very detailed scrubbing of the data behind the summary or even mid-level reports. And then level 3 is generally characterized by conducting field work to go and gather new data. A good example is testing of supply meters for accuracy. So All of that said, the focus of what we will be working on in this program is level 1, a desktop review of those reports that are relatively available and the ones that are kind of there, summary and mid-level reports. But it's good to just know that there are more advanced levels of validation, because that can come into play when we understand the limitations of a particular level of validation. So just to underscore those, when we are conducting a level 1 validation, we are looking for affirmation of where the inputs came from, affirmation of the basis for the grade selection. But a level 1 validation would not potentially correct or even catch errors if they are in the deep raw data. For example, in the account level data of the billing system and what becomes extracted from that, or at the detailed level, the 1-minute polling in our SCADA archives, anything that's deeper than a summary or even mid-level report that has an error may not be flagged specifically from a validation that's at a level 1. One of the goals of the level 1 validation is to identify if there is potentially a deeper issue and provide some insight as to what type of level 2 or level 3 validation activity would best serve to daylight those types of issues. But it's important to recognize that a level 1 validated audit does not equal a fully validated audit, but it is the level of effort and validation that is the focus of this program and the requirement from Senate Bill 555. So let's talk a little bit about the notion of data validity and really ask the question, why aren't our numbers right to begin with? Why aren't all of the data that we extract from our systems and take and plug into our water audit, why wouldn't they already be correct? And what types of things can introduce this uncertainty and this inaccuracy? And we have to recognize that we rely on instruments in many cases to measure supply, to measure our customers' consumption volume, and those instruments by nature are not perfect, and they can, for many reasons which we will get into, produce information that's not accurate to begin with. Secondarily, we have data management systems where the data coming from those instruments goes and lives as archive. That's where we typically go to retrieve this information, particularly when it's time to conduct the water audit. So those data systems can have issues in and of themselves that can create inaccuracy in some of our final numbers. And then lastly, we have our own human interaction with the data, what we do with it. And this is introducing the possibility for error or any type of miscalculation or mishandling of that particular data. I will say that out of all of these potential issues we're searching for, by and large, human error is not the big culprit that we're on the hunt for. We have to be diligent. We have to watch out for that. But generally speaking, those in the water industry are professionals and able to do their jobs very, very well. So it's not necessarily the human piece of this, but we want to be aware and be on the lookout for that when it does occasionally occur, and make sure that we identify and correct it. So getting back to our water balance, we learned about, and Kate took us through in some of the review of those foundational concepts. The two biggest volumes, the biggest volume is the system input volume, and then the next biggest volume typically is our authorized consumption. Well, the accuracy of these two numbers in the water audit and the water balance are paramount. If we have any error that exists in one of those two numbers, it is going to have the greatest amount of impact on our overall audit reliability. So let's examine some of the things that can introduce inaccuracy or error into those two numbers, just so we've got our radars up for the types of issues that can come into. Starting with system input volume, of course, we measure those with supply meters, and those supply meters can come in all shapes and sizes. Technologies, many of you participating in the program may have a Venturi style meter, mag meter, perhaps a positive displacement meter or a turbine style if it is lower or medium flow rate applications. If you have a well set up, that may be more common. Mag meter or solid state technologies are certainly gaining more popularity and use in the water industry. What I will share is that some of the challenges that we're going to work through and talk through and identify that can happen with these supply volumes and how they're measured, they do not discriminate when it comes to technology. These issues can show up in any technology, and be wary of what the meter vendor may say otherwise, but no meter technology that exists today is completely immune from some of these challenges that we are about to talk through. So to talk through some of the potential data challenges that can occur, we're going to use an analogy with our friend Gizmo from the hit movie 1984, Gremlins. If you recall from that movie, Gizmo himself is quite a lovable character, but when he gets wet, he multiplies, and when you feed him after midnight, he turns into a gremlin, and gremlins can do some really nasty and very mischievous types of things. So we use the analogy of the gremlin because the challenges in the data that we can run into behave largely like gremlins. And so let's talk through a few examples, and we'll tie up our analogy further as we go forward. The first gremlin that we can observe is that the supply meters simply wear over time. It's a piece of equipment, and as time goes on and that piece of equipment gets used, wear can occur. And even with some of the newer technologies, such as those mag meters or even ultrasonic meters, wear and tear can still occur, although it may be not of the mechanical nature. But physically, we've got these pieces of equipment that are there. So just as a pretty intuitive example, the meter, when it is worn, is not producing as accurate information as it did when it was brand new. So that one's pretty obvious, and we end up with a supply volume that from the start is inaccurate. The second gremlin we think about is meter location, and this one also should be fairly intuitive. But where we install a meter, it does matter, and we see like this in this particular screenshot, a well meter that sits the red piece just immediately to the red piece, to the left of the red piece, is where the meter sits. So relative positioning to the valve right next to it, and to the 90-degree bend upstream and downstream, this is a really big deal. This is a meter that is not in a place where the flow is conditioned and smooth, and meters generally need smooth conditioned flow to perform properly. Other interesting examples from our friends at M.E. Simpson, where the placement of the meter relative to the check valve in the middle of that run of pipe was creating a situation where the water column and the speed of the water at the bottom of that column was faster and caused the turbine mechanism to overspeed on the meter. Interestingly, this meter had been tested at the manufacturer's facility the prior year and tested out great. But when it was tested on site in situ conditions, it tested at 142%. So it was over registering and by a very significant amount. So this is a great example of this particular gremlin. Relative positioning of the meter installation was creating very, very inaccurate results. Meters, again, depending on the technology, and this is another example of no technology is completely immune from all of these gremlins, is that all meters generally require some degree of upstream and downstream clearance where it's straight pipe without the occurrence of something that would create disturbance in the flow, like a fitting, a bend, a valve, anything like that. So this is a big deal. The other thing to keep in mind is a lot of times these meters and where they are installed, that was a decision that was made a long time ago. And if you're the operator at a water system, typically you probably weren't the one who actually made that decision. And so this is another inherited condition that's not a function of the operator's job performance. It is simply an inherent condition of the system itself. It's the way it was set up, the way it is originally producing this information is producing inaccurate numbers. So we'll look out for that particular gremlin that can introduce error into our supply volumes. Next, we get to the gremlin that is meter selection, and this one is probably more intuitive on the customer side, but I think we all are familiar with the notion that it does matter what meter we put in at a particular location for a customer's usage. You can't just randomly pick a size or type of meter. You need to look at the flow rates that are occurring at the facility and make sure that the meter you select has been designed to accurately read within those flow ranges. And if we're not careful, oversizing or undersizing or even misapplication of the meter type can result in supply volumes that are not accurate. The next gremlin we can run into is the meter programming. The meter has the primary device, which generally is what conducts the measurement, but that information has to get communicated up to the brain of the meter, the register, and perhaps if it's a Venturi style meter, then it would be the transmitter. This is where the conversion may occur, and perhaps it's converted from if it's a Venturi style meter, it might be converted from a pressure differential measurement into an electronic signal, and it's put on a 4 to 20 milliamp range. Well, the settings for what constitutes 20 milliamps or maximum flow, those are settings that have to be programmed in. And if the range is incorrectly programmed or any other settings are misprogrammed, the calculation and the conversion will be incorrect. And this will result in a piece of data that is not accurate. And then finally, we have the gremlin of where the information ultimately goes to live. And once it leaves the brain or the body and the brain of the meter, it has to go somewhere. And typically in an urban system, this would be some type of SCADA or data archival system. And there are things that can occur, some gremlins that can get introduced into our data archival, can look like this. And here's an example of what that can look like. A typical day in the life of a Venturi meter. We've got the first column looking at the time of day. We've got the second column, which is the actual flow rate that was observed at the pump and at the meter. And then we've got to the right the information that was being communicated through the communication system to the SCADA. And we see between the hours of 4 and 10 o'clock there was something that involved or that resulted in an interruption in those communications. And as far as the SCADA was concerned, that was a zero production period of time. There was no water being produced according to what was archived. So you can go to the totals for the day and observe that if we were to go off of the SCADA's records with the gap in the data, we only produced 151 million gallons for that day, when in truth the actual production was 212. So this is a data gap that could occur from any type of interruption, including a surge or a lightning strike, power failure. Those can also be planned maintenance, where the communications are down. So this is a big deal. This is not the type of gremlin that you could see from simply looking at even a daily or certainly a monthly report on production volumes. And you can see here we have to observe it at the hourly level in this example. But these data gaps can also occur in less than 1 hour increments, and so even if you're looking at an hourly report, it may not immediately. So this is an example where a level 1 validation may not specifically identify and correct this issue, but the level 1 validation may flag that this type of potential issue is there based on the other metrics in the audit. And we'll talk more a bit about that later. So there we get to a summary of the potential gremlins. This is certainly not a comprehensive list of all the gremlins that could occur in that system input volume, but some examples of the types of things that can introduce error into the system input volume. By the way, the most important number in the whole water balance is the biggest number, and any issues in that number or inaccuracies there are going to they're going to burden us throughout the rest of the water balance because they're going to carry through. I mentioned that a level 1 validation review on an audit would not daylight issues that are deeply embedded, such as data gaps in the SCADA system or even a supply meter that was producing inaccurate volumes due to the placement of the meter or wear and tear or the selection of the meter, any of those gremlins we talked through. Just to underscore this, some of the more advanced validation activities beyond level 1 that would be utilized to daylight those types of issues if they exist would be both flow testing and calibration on supply meters. This is a way to do some gremlin hunting. And notice we very clearly distinguish differently between these two terms. Flow or accuracy testing is a comparative reading. It's essentially a hydraulic test where we are independently measuring the volume with either a separate meter or some type of volumetric displacement like a drawdown test that is providing us a secondary measurement or a different measurement that we can then compare back to the meter that is in question. This is different from signal calibration or electronic calibration, which is essentially verifying the signal that comes off the secondary device of the meter. And this secondary signal calibration is where we would essentially try to identify those gremlins of programming or possibly gremlins of data archiving if that signal calibration includes checking the data chain all the way from the head of the meter to its ultimate landing spot wherever it's archived, if it's a SCADA system or other. So these are two distinct activities. They are actually both important to do, but be careful in not to interchange these two terms because they are not the same. And when you look at the data grading criteria for supply volumes or volume from own sources, then you'll see that it just treats these two terms differently. And for example, a grade of a 6 asks if you're doing either flow testing or calibration. When you get up to a grade of an 8, it is saying you have to be doing both on an annual basis. So good thing to underscore there, and make sure that we pay attention closely to that. So let's now go to the second biggest volume in the water balance, which is the authorized consumption. And just to touch on a few of these, we're going to walk through the level 1 validation methodology after we touch this. But I want to put this out for consideration that there are gremlins that can live in this particular number, especially the billed metered consumption, which typically is going to be the largest part of your overall authorized consumption. And when you go to extract the volume, the exact volume for the year that was billed and metered, when you ask your billing system to provide that, certain types of gremlins can exist and can come with that. And it's really rooted in the notion that our billing softwares are designed, and most billing softwares do it very, very well to do billing. They get bills out the door and they manage the financials. It was designed as a financial tool. I've never met a billing system that was designed specifically as a water loss analysis tool. And oftentimes what we are asking it to do, while it may be able to accommodate it somewhat, it was not designed specifically to extract those volumes for an exact period of time for the purpose of a water balance and analyzing water loss. So we just need to recognize that, and we're working with those tools that were designed for a different purpose in extracting these. So the types of things you can run into are the gremlins you see there on the screen, and we'll touch on a couple examples as we move forward in this program, and you'll have an opportunity to see what that can look like. And again, with a level 1 validation, it is not necessarily the case that all of these gremlins would be daylighted. However, we are looking for signs that some of these gremlins may be there in some of the other metrics, and we'll talk a bit more about that later. So let's get into the steps, the process of actually conducting a level 1 validation review on the water audit. So summed up in 5 clean steps, first thing we have to do is gather all the supporting documents. It's real tough to assess the integrity of a given number if we don't have any of the information behind that given number. So that one's pretty straightforward. Second thing we do once we have the audit populated is to do a first evaluation of the metrics. And those metrics, or the performance indicators on the water audit, can sometimes tell us a story. And sometimes that story may not make sense. It may tell us some story that suggests that there could be an underlying issue. There could be gremlins present. And having the step 2, where we do just a first look at it, can oftentimes help us steer the ship when we're doing step 3, which is reviewing each of the data inputs and the data grades. Once we have worked through the reporting worksheet, reviewing those data inputs and data grades, we do then probably a little bit more detailed evaluation of those metrics, more so than step 2. At that point, we've been through the worksheet. We've examined the inputs, where they came from, and the grades and the basis for those grades being selected. And we're really at that point looking at those metrics to see if they are generally consistent with our understanding of water loss at the given utility. Then finally, documentation of that process is extra important overall in what came out of the steps 1 through 4. So getting into some of these documents, and just a heads up, this is going to be one of the parts of your homework assignment from this first work session to get ready for the second work session, which will be our teleconference, is to gather these supporting documents. So keep these in mind as we're talking through them. We'll want to revisit this when you're getting ready for your homework and getting prepared for wave 2. Previous water audits, if you've done them, are good to have. If you've got any type of water loss control activities in place, documentation for that is going to be helpful, and we'll look at how that'll be helpful in a bit. If you have not had any formal water loss control efforts in place, that's fine. But if you have any results of leak surveys, meter tests, district metered area efforts, even pipe replacement, capital programs with pipe replacement, that type of information could be helpful just to have for reference. Getting into the specific sections of the audit, water supplied, we're looking at supply meter demographics, and this can be a simple inventory of which supply meters you have, what their size, type, and age are. And to specifically call this out, what we mean by supply meter is the last meter that measures treated water before it enters your distribution system. So if you're set up with a raw meter and then you have some type of treatment process, and then there is a finished meter after, the finished meter is the one that we're talking about. If you have a different setup where you simply have a raw meter and there's not a second meter down the line that's capturing, then of course you go off what you have, and you'll have to use those raw volumes. But keep in mind that we're looking for that measurement of where water is essentially put into the distribution system. We do want to see those by month, but also by supply meter, and we'll talk more in a bit about how that breakdown gets used for the calculations. If you are doing any type of testing or calibration activities, documentation from that is important, and we put that into this list for use when we're developing some of the calculations and inputs for the audit. And then finally, a general schematic of the system to understand how water gets in and out. Very high level, just a general map of that system would be important and can be helpful to do. Authorized consumption, customer meter demographics is helpful. This can also be a simple inventory of meter size, type, and age. Of course, relative to your supply meters, you have a whole lot more customer meters, and so a table that does tabulate the meters by their demographics, by size, by type, and by age can be helpful when you're evaluating some of the meter related and billed metered related inputs in the audit. Monthly water sold, volume by rate code. This is one where we're looking at for your authorized consumption. Typically, most of this is going to be your charge accounts, the ones here, your billing. But this could also include if you do have any unbilled and metered accounts or connections, which may be like a governmental building or something like that. Those would typically have their own rate code that would allow the billing system to distinguish that those are no charge accounts. If you don't have any of that, that's fine, but we're interested in seeing the water sold by month by rate code, and to allow us to through this process to learn about what those different rate designations are and the usage at each. When we get into the review of the inputs, we'll see a couple examples where that type of information becomes very critical for our ability to assess whether or not gremlins may be present. And then finally, if you are tracking any type of flushing, fire department usage, typically those are going to be estimations, and that's fine. But if you have tracking sheets, those are good to include in your supporting documents. Supporting documents for the apparent loss section of the audit. Customer meter demographics is a repeat of the document for the authorized consumption, but we just put it there again because it is something that as you're developing the input or reviewing the input that's already been developed for that customer meter inaccuracy, it may be helpful to refer to those. Certainly, if you have any test data that exists for your customer meters, and your testing activities may range from we're only testing to resolve complaints that come in to we're doing statistical testing every year or somewhere in between. So regardless of whatever test data you have, it's good to assemble that in your supporting documents. Miles of main and number of connections, those are two direct inputs into the audit, and the twist here is suggested to try to get that per zone. If your water system is set up in multiple zones, that will come in handy in developing those inputs for the system, specifically regards to the average operating pressure, which is another one of the data inputs in the system data section of the reporting worksheet. And finally, the cost data section on the gathering of supporting documents. These are budget documents. Usually most utilities have this as a standard report that's prepared every year. It's audited every year by some type of third party that's usually par for the course. So the operating cost, the debt service schedule for water projects, if you purchased water at all for the year, what you spent on chemicals, what you spent on power, if you had residuals or sludge handling from your water treatment process. Those are some specific items that can come in handy in evaluating or developing the input for some of the cost figures. So usually those types of things exist in the standard budget document that's done each year. The depreciation schedule is one that more often than not it would be a separate document, but this is just simply looking at the inventory of the water assets and what is the annual depreciation amount on those assets, and not just the total but the itemized for each asset. What is that amount? So that may be a separate document. Typically you can just provide this type of list to your financial folks internally, and that type of information is usually only an arm's length away. The rate code key is specifically speaking to those codes, those rate codes that we talked about, monthly water sold volumes for the authorized consumption report. Rate code key is simply the legend that would help explain what the different rate codes mean, and it could be nothing more than a simple list that has the codes listed out and a description of each, so that as the person or the team doing the level 1 validation review is looking at those other records, there is a way to connect back on the importance and the relevance of a different rate code. And this becomes especially important when we are looking at charge versus no charge rate codes and potable water rate codes versus non-potable water rate codes. All right, so that gets us into step 2 of the level 1 validation method. We're now in step 2 of 5. And we look at the sanity check. This is this is our friendly sanity check that says if we take an initial look at the metrics and we see something that suggests that our numbers are off. And by the way, this is on the performance indicators tab is where we would be looking at this point, not on the reporting worksheet. But if we see that the numbers are off by a factor of 10 or 100 or a tenth or a hundredth, oftentimes that means there's just simply a units issue on the inputs. And good news there, it's easy to spot and easy to fix. Other things that might not pass the sanity check, if our losses are less than 0 or greater than 100%. If we see that the PIs tab or the performance indicators tab doesn't actually calculate anything, it would suggest that there's something incomplete about the reporting worksheet. More often than not, that means that we have forgotten to enter a data grade. So you can go back and hunt for which grade is missing. And then finally, the leakage index. As an early adopter, hopefully you're familiar with the infrastructure leakage index as a performance indicator. Just a refresher, as Kate took us through in segment 1, the leakage index represents the ratio of our current leakage over the technical minimum for our system. And so the closer that ratio gets to 1, the closer we approach our technical minimum. Every system has a physical limit, a low limit of the leakage that can be reduced to. And so if we see a leakage index less than 1, it's telling us that the leakage levels are less than the technical minimum. More often than not, that just means there is a gremlin somewhere at play. And so as you're embarking upon step 3 in the level 1 validation process, this is helping you to be on alert for potential gremlins. So that's where this is. This really shouldn't be a very long step. It should just be a quick review of the metrics to set your ship pointed in the general right direction for step. We are interested sometimes to look if the metrics falling on the performance indicators tab do fall inside or outside of those typical ranges. At this point, we're not trying to necessarily explain or understand why they may fall inside or outside. We're simply making a note of whether or not they do, and this will help to put us on alert. If we see something that is outside for either the apparent loss or real loss in gallons per connection per day, or the leakage index that is outside of the typical ranges, what that allows us to do is just to be on alert that there is potentially a gremlin in either the supply volume, the system input volume, or the authorized consumption volume that we want to be on the hunt for. And so it helps us to just to stay tuned for that and be aware. The last part of step 2 that can be very helpful and interesting and enlightening sometimes is to take a look at what has happened in the past. And there is a tool that has been developed in conjunction with the free AWWA water audit software, which is the compiler tool, and it is also a free tool. And before you get nervous about having to deal or learn about another software or a spreadsheet-based tool, this one is really just simply a companion tool that's used to take several audits and assemble them in a single sheet and allow you to do some pretty quick and easy charts. That's basically all the compiler is. It's a free tool. You can get it from the same spot that you can download the free water audit software on the AWWA website. And so it's available in the same way that the free water audit software is available. Here we have an example from the city of Cincinnati, where they have several years of audits and are able to simply look at trends in pretty much any input that exists in the audit. So think about the reporting worksheet for every input or grade, or the performance metrics on the performance indicators tab. Any of those numbers, you can use the compiler to just grab and throw a quick chart together and see how is that number trending over time. And in this validation type of gear, what question you want to be asking for is anything out of whack? Is this year's number seem to be bucking the trend or vastly different than historically where it's been? At this point, you're not necessarily trying to understand why or explain, but it does help put you on alert as you're about to embark on step 3 to review the inputs If you see something that's way out of whack, here's another example of just simply the water sold in the city of Cincinnati over the last 5 or 6 years. You can see there's a downward trend. So if you're doing a level 1 validation on Cincinnati's audit, you would look at that billed metered volume, the water sold for 2016, and say, well, hey, that's generally in line with the trend. Our trend has been going down. You might gut check that against what you know about, have water sales been going down, and is that generally consistent with the overall understanding pattern. So just a sort of a guidance tool as you head into step 3, knowing what to look for. Now we get into step 3, which is reviewing the data inputs and the data grades. And the general idea here is that we're tracing the data inputs where they came from. We're using the supporting documents to do that. Now we reflect back on step 1. That's why gathering those supporting documents is so important. It is really difficult to assess the integrity of a number if we don't really have any information behind the numbers, so that's key. Tracing the data grades through staff interviews, note that's really not heavily relying on those supporting documents. The data grades themselves, as you recall, or data grade discussion, is largely dependent upon those policies and practices that are in place at the utility to help inform which number 1 through 10 is the right and appropriate grade as of this year, as of the audit year, for that particular input. And a lot of that, some of that can be gleaned from supporting documents, but by and large, interviews with the folks that are experts at the utility in that department, that relative department, are going to be the source of that information to talk through that. So keep that in mind as you're walking through this process. What we're going to do now is take a look at some typical gremlins as we're working through the review of the data inputs, typical gremlins that we're on for, starting with water supplied. Of course, the gremlins that can exist from those supply meters that we talked about in the earlier part of this segment, those exist. But to reiterate, a level 1 validation review is not going to involve going to the field and conducting an accuracy test on the supply meter. It's not going to involve doing a detailed extraction of the SCADA data. So you just have to be aware that those types of gremlins can exist when we are looking at the level 1 review on the water supplied. In particular, these gremlins are the ones that we're specifically making sure that they're not in there, which are missing or extra volumes, mismatched time frames, calculation of the error adjustment. That's one that can sneak up sometimes, with especially if you have multiple master meters or multiple supply meters. Taking those and appropriately blending them into a weighted calculation is something that you want to do, and you want to be on the lookout for that's done correctly. Plus or minus on the actual error adjustment, you can see here to the right of the volume from own sources, water imported and water exported, there is the ability to enter the number as a percent or as a volume. It's very important to make sure we pay attention to the negative or positive nature of that number. It is, if you forget or ever need a reminder, the note and the reminder comment is provided there for a negative value for under registration, positive value over registration. On the authorized consumption, we have the billing volumes. We touched on these warming up this morning. Remember, these were duplication of volumes, missing volumes, non-potable volumes, and mismatched time frames. Well, how do you look for those when you're assessing this particular input in the water audit? Well, one of those ways is by taking a close look at the summary by month by rate code, and make sure that when we see those rate codes that we have a good affirmation that only potable water volumes are included and only charged volumes are included. And we want to be careful not to double count. In this case, if we have water exported that was utilized in the water exported field up in the water supplied section, we do not want to include that volume in the billed metered. Here you can see the little red triangle to the left of the billed metered input. Our example shows 209 million gallons. if you hover your mouse over that red triangle, there's a little reminder note that says, hey, by the way, make sure if you use the volume in water exported that you do not double count it and include it here in billed metered. Unbilled metered is another one we're looking for. With those two in particular, this is why we want to be able to see the authorized consumption water sold by rate code by month, because it is then that you can ascertain that the water exported, the unbilled unmetered, or excuse me, unbilled metered, and potentially any non-potable volumes such as reclaimed water, raw water, certainly sewer volumes, anything that's not a water volume that potentially could live in your software and get extracted into a report. We want to have visibility on that so that we can be sure it's not included. Finally, on this one, we want to be careful not to include estimation of water lost due to leaks or breaks in the unbilled unmetered number. If you are tracking that, and many folks are, that's a good thing. That information will come in handy later for analyzing your leakage, but for the top-down water audit, it actually does not have a place where it goes. You want to make sure you leave that out. When you are tracing the data grades for each of the data inputs in the reporting worksheet, as you're going through here in step 3 for the level 1 validation, the general approach you want to take is to familiarize yourself with the themes in the grading matrix that exist. And here we see an example of water supplied. You can look at some of those themes. Are we metering the sources? Are we conducting testing? Are we doing secondary device calibration? The types of questions and criteria that are posed in the 1 through 10, they kind of have themes laced through them. So as you sit down and are working through this, it's good to familiarize yourself with those themes. Rest assured that you don't have to have them memorized, because your guide in this is essentially the grading matrix. And you're using the grading matrix and you're conducting those staff interviews. Through those staff interviews, we're determining which grade in the grading matrix is indeed the best fit. And that's the guide. So when in doubt, we fall back to our rule of thumb. We are looking for the highest data grade where we meet or exceed all of the conditions in that grade and the grades below it. And that's how we can work through that as this step 3 for tracing the data grades through these conversations and interviews with the individuals at the water utility who would be able to best speak to that. So that process of working through the data inputs and the data grades occurs here in step 3 for each input, essentially working from the top of the sheet down to the bottom of the sheet. Once that step is complete, once that process is complete for step 3, we take another look at the metrics. And at this point, hopefully we're past the sanity check portion of our experience, and we're really taking a meaningful look at these metrics. Hopefully that we've identified and removed any gremlins so far. But what we're looking at relative to these typical ranges, and just a quick caveat, these are just typical ranges. These are not hard ranges. It is certainly possible that a utility might have a metric that falls outside of these ranges. The guidance here is that if you see a metric that does indeed fall outside, you should be on guard that there could be, it likely would mean that there is a gremlin that does exist, gremlin or gremlins, an issue that's more deeply embedded that the level 1 validation review was not able to, at least to specifically source. But at this point, you can ask yourself, if we're outside of that range, what would be the likely culprit? And you may reflect back on, is there already supply meter testing practices in place? Are there already detailed billing data audit practices in place? Are there areas that are not closely investigated that might be a likely source of a gremlin? So that's really where you're at. Inside of the typical ranges, if the metrics that you have at this point are falling inside of these typical ranges, the next thing you do is ask yourself these questions. How do those metrics align with the practices in place? So are they on the low, middle, or high ends of the range, generally speaking? And is this consistent with the practices and the understanding of the infrastructure? Do we have a very decrepit old network that we know has a lot of age and a lot of deterioration on it? And we don't yet have any type of formal leak detection program or leakage management program in place. Well, for that situation, we would more than likely expect to have higher levels of loss. So if we are seeing from an audit that matches up to that system, if we are seeing lower levels of loss, that would not be consistent. And so that becomes a flag and likely a suggestion that there are gremlins that are at work and that are more deeply embedded in advanced validation activities are needed to help to daylight those. The other thing you can look at is again back to that compiler. Are our metrics consistent with historical? And we looked at those typical metrics, typical ranges of apparent loss and real loss in gallons per connection per day, as well as the leakage index. Well, the great thing about the compiler, if you have multiple years of the AWWA free water audit software filled out and populated for your utility, you can simply put those in a common folder, use the compiler to click a button and bring them in, and select any one of those metrics and chart it and see what the last few years look like. And if this year is drastically different or out of trend with history, then that may be a suggestion that that something is amiss, that needs to be further investigated. Step 5 is rounding out. We're rounding third base here and finishing up the 5 steps of the level 1 validation. Document. What do we document as an outcome of the level 1 validation? Well, for your inputs, document the data source. And I would get as specific as you can. What was the name of that supply report? Where is it kept? Where does that supply report live on our shared server, for example? What was the name of the billing report? That's one where every utility may have their own version or their own name that they call a specific billing report. You also can derive a billed volume from more than one report. You could get it from the monthly register or the monthly summaries, or perhaps it came from a detailed query that had account level detail. Put this information down in the notes for where it came from. You're going to greatly appreciate that months down the road when you pull this out. It allows it to be traceable, it allows it to be transparent, and it allows you to quickly recall where it came from. Same for any deriving of the numbers if the calculations were performed, if you had to make any assumptions, and if you got through it and there was an action needed, such as we had to make an assumption on the error adjustment for our supply volume because we didn't have a copy of the test report from the test that was conducted last year. So we need to make contact with the company that did the test and get a copy of that report. That's a really good thing to write down, because then you capture that it's an action, and that way it helps it not to get lost, and helps to establish that for reference in the future. On the data grade side, a lot of the same types of things need to be documented. In particular, this is what is the basis for selecting that grade. If you decide, for example, on a given input that it needs a grade of a 6, it's not so much necessary just to simply rewrite all the criteria for a grade of a 6. All that's in the grading matrix already. But I would, if you were going through that process and you read an 8, and there were 1 or 2 things that were not met in an 8, and that was the reason you chose a 6, that's a really good thing to write down, to make yourself notes about that, so that it will be easy and quick to recall in the future when you look back on why a certain grade was selected. Any assumptions needed, and of course action needed as well. When you are reviewing the metrics in step 4, asking those key questions about how those metrics align with the loss management practices and the condition of the infrastructure and the history of that particular metric, write down your observations. Is it consistent? Well, make that note. Is it not consistent? Make that note. These are the types of things you'll want to be able to refer back to and also make it traceable and transparent for others that may need to understand how this was evaluated and the outcomes. And above all, if there are issues that you believe are still in existence, once you have gone through this and checked the metrics for consistency, if you find something that's not consistent, or for any reason believe that there may be a gremlin at play that needs further investigation, doing a thoughtful narrative about that is critical, so that you have actionable steps forward. You have a way to go forward. So if you get to this point and determine that supply meter testing has not been conducted in the past, and you have metrics that are not making sense, and that seems to be an appropriate next step, that's a good thing to note here, and why. So where do you note all of that as I'm describing these comments and making these notes? Well, there is a built-in feature in the water audit software, as you hopefully are aware if you're working with version 5.0, the latest and greatest version, that allows you to capture all of these things in right there live in the software. The great thing about that is that it's embedded, so it lives with the tool, and that file has that information in there. And so whenever you go to pull the audit back up, all of the comments and notes are connected. The downside is that it's an Excel format, and you have a cell that you put information into, so you're a little bit limited on what you can put in. You can put in text, but you can't put in images or other things that are just not text. So if you wanted to do screen or perhaps tables or anything like that, you could consider doing this, which would be simply a separate document. That maybe it's a supplemental document. Maybe anywhere else you wanted to capture something that the comments tab in the tool would not accommodate, then you just simply make a sheet that follows along with it. That's your choice as you go through this process, but I would encourage you to make sure you've got a good trail of breadcrumbs to recreate how the input was derived and where it came from, and how the grade was selected and the basis for that. So that gets us through step 5 and to a wrap point on our presentation regarding level 1 validation methodology. What we're going to do now is to talk a little about wave 2, and the exciting part about wave 2 is that we're moving from a group setting where our team is working with many utilities at a time into a one-to-one setting where our team will be conducting a teleconference with your utility team specifically, so it's a one-to-one. In doing that, we are asking that you do a little bit of homework. We do have a couple things that we would like to ask you to do in preparation for that. One of those things is the supporting documents, which include your most recent water audit. This would have been the water audit that was included with your urban water management plan that was submitted in July or by July 1st of 2016. So you may have been involved in that process. It's possible a consultant may have been working with you on preparing that. Hopefully you were involved to some degree, because the data that goes into the audit has to come from the utility, and this is definitely a group activity, not a solo sport. But if you have any questions about that, refer back to what was submitted in your urban water management plan. Beyond that, we talked through each of these documents earlier in this segment, so you can reference back to the recorded content where we talked in detail about these. But we are asking that you gather as many of these as you can and provide them to us ahead of the Wave 2 call. And in a moment, I'll talk about scheduling the Wave 2 call, when that'll happen, etc. But the caveat with gathering this is if we're asking for something and you just can't get it together, you can't put your hands on it, or perhaps you can put your hands on it but not exactly what we're asking for, but some version of it, that's okay. Do the best you can. This overall program is set up in a 4-wave format. This will be wave 2. Waves 1 and 2 are kind of like a dress rehearsal for waves 3 and 4. And wave 4 constitutes or culminates in the submittal of the level 1 validated audit for next year to the state, and that satisfies your regulatory compliance with Senate Bill 555. So that's opening night if we're using our Showtime analogy here. This is dress rehearsal. So if there's something you can't get to that we're asking for, don't sweat it too much. Certainly reach out to us with questions as you're working through gathering this information and you run into questions. We're there, and I'll put the contact information here at the end of the segment. Water supplied, authorized consumption, apparent loss, and system data. Again, these are the supporting documents we talked through earlier on this segment. If you want to review the discussion on those, I would encourage you to rewind in the recorded content and just take a look at that. And if you certainly have any questions as you're preparing and gathering this data, again, out to us, let us know. Finally, the cost data wraps up the list of supporting documents that we are asking for in preparation for Wave 2. And so let's talk about the scheduling of that Wave 2 teleconference. What we're going to do is to reach out to the primary point of contact for your team, and we will ask that primary contact to take a look at the other team members' calendars, the other team members' availability. We will make a master schedule available to you, and on there it'll be all of the time slots that you could pick from between October and the window that we're doing our teleconferences in. And it's basically a first come, first serve basis where you pick the one that works best. So it is encouraged to do that sooner than later, so that you make sure that you get the time slot that you want, and all the good time slots don't get snatched up. But we'll be in touch with you soon after your completion of the Wave 1 workshop about getting that scheduled, and we'll look forward to talking to you then. As always, thanks for watching this segment. We appreciate your reviewing this recorded content in preparation for Wave 2. We're excited to spend some time with your team in a one-to-one environment on that teleconference. If you have any questions, the first place I would suggest always to go is to our in-program website, which has resources about the types of materials that are being used, the 4 waves. At any given point in time, if you just need a dashboard to get oriented on where things are at, more often than not, your question could get answered by checking out californiawaterloss.org. In the event that doesn't do it for you, or if you just simply want to reach out to us and ask us a question directly, or just to say hey, feel free to email us at waterlosscontrolcollaborative@gmail.com. Thanks again for watching, and we'll look forward to talking with you soon.